Hi, so I will be presenting you the Cloud Native Task Manager application that I developed using the AWS services. And as we can see, I will first go through the architecture diagram as shown here. I have utilized many services such as Amazon CloudFront, Amazon S3 bucket, Lambda for serverless processing of our application, EventBridge, API Gateway, and Elastic Beanstalk, which is the platform as a service for providing easy to deploy platform for my Java backend, Java Spring Boot based backend service that I developed for handling the task management. Now, if we look at the architecture for this particular application that I developed, the first access point for the end users is the Amazon CloudFront point of presence or the edge locations, which reduce latency for the end users and allow the website to be accessed closer to the locations of the end user. So I have utilized Amazon CloudFront for that, and my CloudFront is basically accessing the Angular based web application from this particular Amazon S3 bucket, which holds the Angular application that is uploaded onto this bucket. Now, now when the user will click on this CloudFront link as shown like this. So as you can see, I have pre-populated a few sample dummy tasks, which are basically the object that we have, the list of task objects that we have at the backend. So I have pre-populated that to show on the home page of my application. I have created the filter for the tasks as well, as we can see. Now, there is also a functionality to search the based on the title, as we can see. So these are the two functionalities that we have at our disposal right now. And apart from that, there is also the functionality to add a new task as well. For example, this is sample title, sample description, and this task is in progress right now from CloudFront. I will write this as well. And the due date is, let's say, 29. So I will create this particular task. So task is created successfully with the status message as shown. And I created this task just now. So this is my task. Right. This is my task. And this is the sample description that I have. The status is in progress right now. Now I do have the option for editing as well as deleting the task. So first I will show you the process of deleting the task. Let's say this database migration task needs to be deleted since I do no longer want to go ahead with that. So as we can see, the task reduced from number of task reduced from 6 to 5. Now let's say this task is in progress, and right now I want to show you my Amazon X3 bucket that exists. So this is an older object that I was using for testing. But let's say if the date time is different, 2046. Now, if I complete the status from in progress to completed, then it should trigger an EventBridge object. Basically, it should trigger the Lambda function based on an EventBridge rule. I am applying a filter on EventBridge as well. That basically checks whether the object has the status as completed or not. And I will take up this completed task object and basically store it in my S3 bucket, as we can see. So right. So this is the object that is basically stored from the trigger of the EventBridge rule that I had created using AWS serverless application model, SAM CLI. I will demonstrate that later as well. And if we look at the contents of the uh, object, so yeah, this is exactly what we just created, the sample description from CloudFront. Now, at the same point, this is what I was talking about. This is my Lambda function, and this is the event bridge rule that I have created that basically triggers my Lambda function as soon as I get the status as completed in my event bridge. Now, I am calling this event bridge, I'm pushing the data into event bridge from my Java Spring Boot backend API. I will later demonstrate that as well. Now, this basically I'm using Porto 3 for initialization of the S3 bucket. I'm basically logging my data as well, which I'm getting from the EventBridge event. And basically I'm creating a summary object, uploading to Amazon S3 and returning a success response basically on how I'm handling the data. So the API, basically the serverless function is pretty simple and straightforward here in this case. And so this is how my Lambda function is basically executing. And I do have the option of creating a task as well, as I demonstrated from this form. I do have the option of deleting a particular task as well. And as we can see from this particular image, and now I would like to show you my Elastic Beanstalk environment as well. So this is the Elastic Beanstalk environment that I created for my Java Spring Boot application that I deployed. And as we can see, the Java Spring Boot application environment is healthy. And this is the domain name that I have um, for my Elastic Beanstalk application. Now, when it comes to the architectural decisions, so I deployed my application on Elastic Beanstalk because it is basically a platform as a service and provides me easy and quick steps for deploying my web application. Basically, my Spring Boot Java backend service in this particular case, and it runs on HTTP. And I had some architectural decisions to make. Basically, I had the choice to use Route 53 domain to basically reroute it to HTTPS using an SSL certificate. But since I did not have a paid certificate, ACM certificate at my disposal, so I basically utilized API Gateway for the creation of basically my HTTPS endpoint that I have at my disposal. And I would like to demonstrate that as well. So this is I think that's the Amazon Event Bridge. Let me show my API gateway as well. So this is the task management RESTful API that I have at my disposal. And this is the get API or post, delete, get, and put. And I have enabled CORS as well. As we can see, now, for the purpose of enabling CORS, I have just enabled CORS for the exact CloudFront API URL that I have. I have not allowed all the URLs uh, for the purpose of safety and security um, in my application as a best practice. So the reason why I used API Gateway because it provided me a quick and easy way to manage all my RESTful web APIs that I was creating, and it also had the functionality of being deployed on HTTPS because my CloudFront is being served via HTTPS, and I want my APIs as well to be running on HTTPS, as we can see. This is the domain name of my CloudFront, and I configured the behaviors in this particular manner. I also invalidated the cache a few times as well. I would also like to show you the particular, right now, the web application firewall, which basically protects from DDoS, is disabled uh, for the demonstration purposes. But if I were to go in a full-blown production environment, then I would probably even use enhanced web application firewall protection, which basically protects from DDoS attacks. And I would create some rate-based rules that can help my protect my application from common attacks such as SQL injection, cross-site forgery, as well as DDoS. And I would like to show my Amazon S3 buckets as well. So this is the catalog bucket that basically I have created. I have separated these by dates. So this is the most recent trigger object that we created. In our application. If we complete any particular task from, then it will basically create an event, deploy the latest version to production application. This will basically create a new object, as we just saw here. A new object has just arrived based on the Amazon EventBridge rule. And I would also like to show you my uh, SAM CLI that I just used. So this is basically my template URL, template YAML file that I created, which basically you provided the infrastructure as code layout for my serverless application model to basically work. With EventBridge, Amazon S3 bucket, and Amazon Lambda function, AWS Lambda function. And as we can see, these were the resources to be created, and I deployed them as per the commands of the SAM deploy guided terminal. And as we can see, these CloudFormation outputs were deployed from the stack. And I would also like to at last show you the Amazon S3 bucket that I had created. So basically, this cloud task management bucket is the bucket that basically contains all the artifacts of my Angular build that I generated from terminal and pushed onto this particular bucket. And then I attached and then I made this bucket as private as well. And I attached a bucket policy, basically, which allows my CloudFront to access the contents of this particular bucket, which is recommended and the best practice as well. All the public access is blocked on this particular bucket, and only users will be able to access the web application through the CloudFront, which is exactly what we want. And I have configured the exact allowed origin for my course request as well, basically to allow the two different domains to interact with each other so that they are not blocked with regards to access. So basically, this was the whole summary of the cloud native task management application that I developed using multiple AWS services, best practices. And in a full-blown production environment, I would probably have a private subnet as well, along with my public subnet in a VPC, which will provide me additional security and isolation for my resources. I would have the Amazon RDS Aurora or RDS PostgreSQL, basically for storing my resources in a relational database that I have in a private subnet, so that they're secured from public access. And I would have to use NAT gateway or NAT instance in order to provide internet access if I have some kind of data enrichment process running close to my private resources in a private subnet. And I would keep my CloudFront and every public sharing public resources in public subnet that needs public internet access using internet gateway. And I would also probably employ a network access control list if I want to provide additional security based on rules at the subnet level that can provide me fine-grained control and can help me further secure my application. I would also basically end-to-end automate my infrastructure using infrastructure as code and best practices using Terraform, CloudFormation, and SAM templates. I'm already using SAM right now, but I would end-to-end automate it, the entire process for the VPC and all using CloudFormation stack as well, just to ensure that any code changes are properly and thoroughly reviewed by fellow developers. So this is it for my presentation of my cloud native application that I have created. And this was my Elastic Beanstalk, the API as well, just to show you at last that this was the data that I was getting from the API. And I have the pagination as well that I have created for my JSON response that I am basically handling at front end as well to show the page number wise contents here as well. And this is what I have at my disposal, the four options. So if I create more than 5, 6, 7, so I can go to the next page. Yeah, thank you so much.